I'm Maren Hunsberger. I'm a science communicator and host for Seeker. And this is the Lightspeed Learning Playlist, all about solar energy. You probably found your way here by way of Seeker's awesome documentary series with YouTube originals on the 2019 World Solar Challenge. In that series, you'll get a chance to join Veritasium's Derek Muller on the ground in Australia with Seeker, where 44 teams from around the world compete in an incredible race across the outback. Teams of engineers and innovators push their limits in their one-of-a-kind solar race cars to cut across roughly 3,000 kilometers of desert from Darwin to Adelaide, powered by the sun.
This is a tough race. It is the premier, most difficult solar race in the world.
It's got hot racing action, pun intended, daredevil driving, uncontrolled spinouts, and fiery crashes. It's got tears and triumph. And it features loads of innovative technology, from the latest solar arrays to top secret batteries to innovative aerodynamic design, which brings us to this learning playlist, where we take a deeper dive into the science and technology behind the World Solar Challenge. That's right, over the next 7 chapters, with some help from Derek, we are going to learn all about nuclear fusion, understand how solar panels turn sunlight into energy, go under the hood of a solar race car, break down batteries and build better ones, dig into aerodynamics, and finally, explore the future of solar vehicles. After watching the Lightspeed Learning Playlist, you'll be one of the foremost experts on solar power from start to finish. Or at the very least, you'll have a pretty solid understanding of how it all works. And just a heads up, each chapter of our playlist will build on the previous chapter. So although you can skip ahead and you're welcome to watch the playlist in whatever order you choose, you'll probably want to watch in the order we've laid out. So let's start with a little brief on what we know about the sun so far. Travel back in time with me to sometime around 1223 BCE. The oldest known record of a solar eclipse is from around this time and was found in the ancient city of Ugarit in what is now modern-day Syria. Since then, our methods for studying the sun have grown more and more sophisticated. Now, it's kind of mind-blowing to realize that up until a few decades ago, our knowledge of the sun only came from observations made from here on Earth, which is approximately 150 million kilometers away. And then came the space age. In a little over 6 decades, we've sent more than 8,000 satellites into space. And there have been several important missions undertaken specifically to help us get a better understanding of our sun, including the Ulysses mission, the Solar and Heliospheric Observatory, or SOHO, the Genesis mission, Hinode, and IRIS, the Interface Region Imaging Spectrograph. These missions, along with several others, allowed us to get a much deeper understanding of our sun. They gave scientists the opportunity to collect an actual sample of the solar wind, measure the sun's magnetic fields, and uncover how solar material moves through the sun's atmosphere. More recently, NASA launched the Parker Solar Probe, the mission being to touch the sun by flying into its corona. That's the outermost part of the sun's atmosphere, providing us with a better understanding of how heat and energy move through the sun's corona and what accelerates solar wind. And even more recently, the European Space Agency and NASA launched the Solar Orbiter to answer our fundamental question about how the sun is able to create and control the space environment throughout our solar system. Both of these missions will get within Mercury's orbit too. And the Parker Solar Probe will get as close as 6.16 million kilometers to the sun, which I know may not sound very close, but keep in mind that means that the solar probe will be too close to the sun to directly image it. Thanks to centuries of observations, we actually know a lot about our sun. We know that it's a yellow dwarf star whose gravity helps hold our solar system together. We know its size. We know that it's a giant ball of gas composed mostly of hydrogen and helium, which when combined make up more than 98% of its mass. And we even have a widely accepted theory for how the sun formed. Out of the collapse of that same giant rotating cloud of gas and dust that formed the rest of our solar system. But it's only been within the last 100 years that we've come to understand how the sun generates its power by a complicated process known as fusion, which pretty much sustains all life on our planet. To learn more about this amazing process, stick around for the next chapter of our learning playlist, where we break down exactly how the sun generates so much energy.